All right, I guess I'm going to start then. Um, I put together a presentation using present terms, so that's what I'm going to use for this. It's got like little GIFs and stuff that I made. So this talk is about composable systems with NixOS microVMs. Um, there's a repo for this. It's public right now if you want to pull it up or like follow along. A lot of the stuff in there is pretty bespoke to like what I'm going to show you. Like I have a specific script for doing migration later, so that's kind of hard coded to my machines just to make it hopefully go seamlessly up here. But other than that, you should be able to just follow along with like examples or poke around if I'm speaking about something. Um, yeah, so a little bit about me. I'm Alex Decious. I go by a DC or however you want to pronounce it online. And I've been using Nix now for like a year and a half. And I'm currently Nixing at Shopify, working on their Super Nix monorepo. And it's really fun. Um, yeah, and I have like a pretty big home lab at home. I do a lot of like self-hosted infrastructure. I have a pretty huge machine with like 256 cores. So we do like some build farm stuff. Me and my friends and some other colleagues build some kind of crazy, stupid projects on there all the time because it's just compute sitting there. Um, yeah, so I guess before I start, like my favorite part about these types of talks is like discoverability and exposition for these things. So a lot of the super deep dive talks I think are meant to be like, watched when you're in a mood to study and like really get into the weeds. And a lot of talks like these are for like showing people these types of concepts that maybe they weren't exposed to before. So maybe some of you guys are like really avid Nix users and you guys will already know all this, but if there's at least somebody out there that doesn't really that's not too familiar with like micro VMs and using NixOS configurations with them, this is for you guys. And hopefully it gives you some cool ideas for stuff you can do after the fact. So first off, like I always get asked like, what even is a micro VM like versus like a normal virtual machine? Maybe like a show of hands. Do you guys actually know like really what a micro VM is versus just like a normal VM? There's like there's like one guy moving his hand like this. That's it. But so basically the definition of a micro VM is it's basically a normal virtual machine, but it's one with an extremely minimal device model. And what that means is it's optimized for like really low resource overhead and fast startup because it doesn't try to assume all of the legacy support or full emulation of these devices like a normal VM does. And like a normal VM, it has its own guest kernel and it uses VirtIO, which we'll talk more about to do all the like host IO stuff instead of like actually doing pass through of physical devices you might have or like fully emulating these things like a NIC or something. So like we'll go through like some of the differences between these things like pretty high level. So like a container, this one uses the host's kernel, and it's good for process isolation. This is, very popular. Most people, when they're spinning stuff up, will just use a container. Docker really popularized this. And one of the problems is, though, I think a lot of us can agree that the Linux kernel itself is a pretty large surface area as an attack vector for things. And when you're supporting so many devices, you have so many open places where like an exploit can happen, or if somebody is able to actually get control of the system, then they can just look at, your secrets on your main host machine. So a VM is different than this. It has its own guest kernel. It'll use like compatible PC compatible devices. It'll either do like direct pass through or it'll do full machine emulation of different pieces of hardware on the machine. Um, and as opposed to a micro VM, which also has its own guest kernel, like you could call like a microkernel, it's running its own. But this one has a much more minimal footprint. It's much more intentional. The devices that it supports are a much more minimal subset, and it uses VirtIO drivers almost as much as it can. So VirtIO itself is really cool, although like when I first got into it, it's kind of hard to understand what's going on here. So high level overview, it's basically a standard family of virtual devices that you could use to do communication between some isolated box and then real hardware. So this works for networks, disks, file systems, consoles, all this stuff. And it's used by both virtual machines and micro VMs. And the way it works is you'll get a driver, essentially a para-virtualized setup where you are aware of being virtualized. One of the big wins for these machines is being fully aware that they're virtualizing, being able to communicate with the VMM, which we'll talk more about in a second. You get big wins for this. So how it works is you'll have this driver on the machine available through dev, and you will be able to put you'll be able to use it normally. It puts it into a virt queue essentially, and then those requests will go through the actual VMM and then end up executing on the real hardware that you have and then sending that back in. This is a little bit simplified, but I think this is a good intro to this just to give you like a high level overview of how this is working. So there's two big drivers, I guess, in VirtIO. These are the main ones that you would need to set up for a project I'll show you in a bit called microvm.nix, which is really cool. And network and disk persistence are those two. So as far as network stuff with VirtIO, this is kind of the life cycle. So you'll have like basically from the MicroVMs perspective, it's aware that it's virtualized, but it's a NIC, and it uses that. It passes through the boundary to the host, and then that will go through a tap to a bridge, which is like a software switch on the machine, and then that'll actually get to the real network card. And this isn't the only way to do this. This is just one way. You could actually have a dedicated NIC on your machine, like a port, physical port, and just bind that directly to the MicroVM if you want to skip this, or you can have a tap go directly to that. The bridge is there if you want to use that same port for other traffic, instead of just being exclusive to traffic going to this MicroVM. So if you had a whole network of these guys on one machine, like 10 MicroVMs, each one would have a tap and it would all connect to one bridge using the same port, and then that would shell out to the actual internet. Next, for like persistence on disk, pretty similar concept. These are actual volumes or storage on your host machine, and these can be mounted or just regular files. So you can basically make things available through like a VirtIO block device, block storage. You can have temporary storage. So if you bring one up and you want it to be fully ephemeral, it'll just get a temporary disk that will be completely wiped. Or if you want more persistent storage, like an example we'll give later for like a game server or something, you'd want to persist that storage. You can just hook that up. And you can also pass other mounts to these machines. Like if you want to mount your NIC store like read only, so you don't need to basically rebuild. A lot of these are also write, no write allowed, like read only. You don't want it to be able to modify some sensitive areas on your disk. So I mentioned it before, a VMM is basically the program that runs in user space. This is like the thing that's managing the lifetime of these MVMs or VMs. And these govern like how much memory one of them gets, like the devices that it gets, its life cycle, vCPUs. And on Linux, this uses KVM, which is the Linux kernel for virtual machines, not keyboard video mouse like I thought it was forever. And yeah, there's a couple different types of these. So these are a few really popular ones. So QEMU is really popular. It's the de facto for normal VMs and for testing stuff. It's really well set up. It has really broad emulation support. It's like for full virtualization, but it's also available for MicroVMs as well. There's CrossVM, which was for Chrome OS, and this was like the original, I believe, for like sandbox devices used like in the browser. And Firecracker, I believe, was based on this or used it as support. This one was like the first big MicroVM used by like AWS Lambda. This is used to spin up like these ephemeral little runners for like CI. That's probably one of their most popular use cases. And yeah, it's heavily used in AWS. And then Cloud Hypervisor is like a generic cloud workload VMM. The name is a little confusing. It doesn't have to be on the cloud. But this one is one of my favorites. It has a pretty cool set of features, and I'll show you one of my favorites in a bit here. So now we get into, there's a library made by a guy named Astro, microvm.nix. This library is really, really cool. It basically gives you a flake with these outputs, these modules you can import onto your machine for a guest or a host. And basically you can define like, here's my NixOS configuration, and here's the guest properties of it. How many vCPUs do I have? How much memory? How much, what disk am I using? And then on the host, there's a module as well where you can declare your guests on the machine, and it gives you nice systemd services to kind of manage these imperatively as well. One caveat to doing full declarative MicroVM setup is after probably 10 to 12 devices, if you have all of these, it may become a little untenable to evaluate all of them. Although I haven't really run into this issue myself, but in a much larger setup, this might not be as viable. So the more imperative approach might actually be preferred in this case. So this is what it looks like for just a dev box. We'll use this as a demo in a second. I'm defining a NixOS machine dev box, and I'm just going to give it the MicroVM guest defaults. I have it in this repo. You can check it out. Something for my user. We're going to put GNOME on it, Firefox, and then we have a little GPU demo I'll give in a second to show the VirtIO for the graphics. So yeah, basically what we're going to do is let's go over here, dev box. And what this is going to do is it's going to spin up a QEMU VM. And if you look in that, that guest, if I go back one, in that GPU demo, you'll see I've actually defined as a VirtIO driver the GPU I have on this little GPD pocket for a laptop I'm presenting on, which is an AMD Radeon 890M. So if we go back over, you'll see like this, we're in GNOME. And let's open console. We can do, I think I named it GPU proof or something. Yeah. So you can see we actually have this graphics thing pass through. You can see it's like VirtIO set up. And if we open like Firefox, we hope it'll work on the Wi-Fi here. Shader Toy. This is like a fun website where people upload like shaders they've made for cool graphics and stuff. And I'll just show you, once we load this in, it starts using it. The GPU on my laptop here physically will start cranking. Here, this one looks cool. Oh, let's reload. There we go. So yeah, check it out. My graphics card is being used. I could open BTOP and show you more, but I think this is sufficient. But yeah, it's using the actual graphics card on my machine. This is not GPU emulation. It's not pass-through of the machine. It's using it through this VirtIO driver that's communicating with my graphics card on this machine. Cool. So yeah, and this is like para-virtualized graphics. Para-virtualized is just the non-fully emulated, non-pass-through. Like this is, it's aware of being virtualized. That's kind of what that word means. Yeah. So I just did DevBox. This is to show like the NixOS composition part of this. The greatest part about NixOS is it gives us a lot of stuff for free. We can just basically declare these machines and then use modules to compose them to do different things. And we can start with the same like base machine image and make a couple of variants of it together with a couple modules like you saw a couple slides back. So like DevBox, you saw we gave it a GNOME desktop and we gave it graphics. We could have a game server with a persistent mounted volume if we wanted to save like our world data or back it up. And then Vault, like a Vault Warden, you know, sensitive service or something that you want. And then maybe some like local access to it, since maybe you don't want that to be fully public. So it's not, you don't have to use a new configuration language to set up all your devices, like your actual host machines and the microvms you would want to run on them. It's pretty intuitive. If you can write some NixOS configurations, you can basically just put this microvm.nix module that's supplied by microvm.nix on there, whether it's guest or host, and then whatever you want it to do. So here's another demo. We'll do the Vault one. This one's just running, I think it's just Vault. Yeah. And this is just going to boot up headless. And if we actually go over to my browser, you'll see like this wasn't working before, but it's hosted on 8080 is what I have it set up for, and local pass-through just for my machine. So if I refresh, hey, there we go. We have Vault Warden running locally in a microvm on this computer. And just because it's running in a microvm does not mean it's safe. Microvm does not equal safe. It just means we have an isolated kernel. We are doing device pass-through, or we're not doing device pass-through. But obviously stuff that happens inside could still be unsafe for the service itself. Yeah. Let's just kill this guy. So one of my favorite things about this kind of paradigm is you can think of machines, these instances, as like units that you can just kind of place wherever you want, these blocks. So you have like the guest configuration, which is like, you know, the modules on the machine, how you like whatever services you want to run on it. You have the guest kernel and the actual runtime state on this machine. And all of this is just one unit. So when you start thinking of a machine as a unit, you can start doing really cool things with it, like snapshotting the whole thing, which Cloud Hypervisor lets you do. You can move it between machines. You can back it up and restore it, like putting it on ice and thawing it out. And you can share it. So if I have a game server set up and you don't know too much about setting that up, you could just copy it and now you have a game server set up for yourself, as long as you just set up the networking for yourself. So I'm going to give a cool demo. I hope it works. This one is, I set up a script, but it's a little bit more involved. The idea is we're going to migrate a live Minecraft server. I'm going to connect to it, and we're going to move the thing from one host to another while I'm connected, and I'm not going to disconnect. So what actually has to move for this to happen? NixOS gives us some of this for free. We basically have the closure, like all the stuff on the machine already predefined, the kernel, the init system, all the configuration is already all defined for us. Now the volatile stuff is like the actual memory, the CPU state, like the device state, and all the active connections to that machine. And a lot of these services need to maintain like some kind of writable medium, like for logs and stuff like this. If you've ever set up a service that is expecting to be able to write to something and you have a declarative setup, you've probably run into a situation where it craps out because it's like, I can't write here anymore. So yeah, we're going to use Nix to build the machine, the MicroVM itself, and then we're going to try to migrate it. So before the move, I'm going to use Cloud Hypervisor 53. We're going to assume we have a matching CPU profile and KVM setup, and we're going to have the same closure on both machines built and put on there. So in this repo that I have a little NixOS configuration module set up that I have imported on 2 real machines back at home sitting on my desk. We're praying that they don't crap out. And that's basically setting up this consistent environment on there. And I'm going to use like a local IP. So I just have a sub route set up through Tailscale on this machine, tunneled back home, and we're going to use that. And we're just going to assume this 10.10.0.70 is the one. So this is the actual little mini rack we're going to do it on. It's the top and bottom of those 3 Lenovo mini PCs on the bottom. The middle one is doing something else, so I skipped over. So yeah. So I already have Minecraft open over here, and I'm SSH to both of these machines. So if we just do a btop, let's make this a little bit bigger so we can see. On this one, I named the 3 after the fates because I like naming stuff stupidly. It's fun. So we have Atropos, Clotho, and Decious. That's even how you pronounce it. But so Atropos is the one that has Cloud Hypervisor running on it right now. It has the game server. So we will go ahead and connect. Trying to play with this like little trackpad is going to be kind of weird. And we hope we can connect through the tunnel right now. And then if you look over here on this guy, we don't have anything running. It's just running stock. And I ran this before it started. Nice, we're joining the world. Just to start on one of these 2 machines, I have one to stop it, and then I have another command to do the swap. And it's going to spit out some output from Cloud Hypervisor and just show us what's happening. And it'll tell us when the swap has happened, and hopefully we won't actually notice anything as just a player. So I don't know. Let's see what we've got here. Let's find something that like moves around, like a animal or something. Or we can just be breaking blocks. I don't know. Let's go ahead and start the swap. I will make it like this so we can see everything on the same page. It should be migrate swap. So it's going to read the state on both hosts. What's actually happening is it's going to make sure the same conditions are on both of them. And the cool part is it's actually going to be swapping over page files, dirty memory, in real time between these 2 machines. And when the delta is small enough, it will actually just swap over. And there's a small amount of downtime expected. But like it's not big enough for us to notice. So we have the initial host state saved. There's a chicken moving around, so we'll know if it stops moving, something has happened. So the destination tap and little firewall that I set up is ready on the machine that this is going to end up on, the destination. And now it's preparing an identical micro VM to this one on that one, syncing the volatile state between the 2. and it'll swap when the delta is small enough. Okay, it's copying over. And I basically just made a little timeout strategy. If I do timeout, just cancel a full transfer. Don't leave us in some half-baked state on the machines. Here we go. We're actually copying over memory. The destination is running, and we have swapped. The source VM is done. We noticed nothing. It physically moved from one host to another, two physical machines. Granted, this is just about as optimal of conditions as you can hope for, two identical machines running the same CPU. But, I mean, come on, that's crazy. Like, oh, yeah, we can show it. Let's make it bigger. So we can see Cloud Hypervisor is no longer running on this guy, and on this one, it is running. We have actually just moved between two hosts. I mean, like, this is a supported feature of Cloud Hypervisor, but that's so sick. Like, we moved physically between two hosts. That's crazy. And like players connected noticed nothing. Like we are none the wiser. So yeah. Thank you for listening. I hope, if nothing else, like maybe this gives you some cool ideas for some wacky things you can set up on hardware you own. This stuff is usable for like in the cloud, you know, for work, production stuff, but you can also use it personally. And I make pretty heavy use of it myself. And I think it's a really cool paradigm for setting up like dev boxes for friends to use your hardware. You can basically give them an isolated box. You trust them, but maybe not that much. Like game servers, you can let people SSH into the game server running. Or like I guess more prevalent now is like if you want an AI agent running in a box and you don't want it to accidentally be able to nuke your machine, you can give it a microVM with all the little tools it needs and then let it spin from there. But yeah, thanks for listening, guys. I forgot I can take questions, but don't ask me any questions that are too hard because then I'll look stupid.
I'm going to take the microphone.
Oh, this one? Here, you want me to move?
I was going to take this microphone. Question you can ask.
If anybody does have any questions, Tristan will go around and give a microphone to you so the live stream could hear you as well. There's one over here.
Hi. For
like, I can't hear you though. Should I wear some headphones too? I can just wear them. Hello?
Hello?
You're kind of quiet, but I think I can hear you.
Is that better?
Yeah.
For self-hosting services, would you suggest doing this or just for a microVM or just normal services with just module with Nix?
You can put services directly on a machine, and I think that's fine. But if you're worried about some service being breached in any way, then they have access to your host machine and all the other services running on there. So putting it in a microVM kind of gives you security. Like if there's some kind of kernel vulnerability or they can get through whatever service you're running, like let's say Vault Warden had a critical breach and it gives you like, you know, root access to the machine.
Yeah, probably for like services like Vault Warden,
yeah,
like out of sync with upstream. So
yeah, absolutely.
Like the patches.
I like to do this for game servers and stuff because also dev boxes. I host a lot of servers for friends, and a lot of times it's cool to be able to give them access to the machine that their game server is running on if they want to tweak the config files themselves or like restart the machine running. You can use, there's some pretty cool, I scrapped it for this demo because I feel like it would be too much stuff, but one of the things I use pretty heavily is a Rust library called IRO. It's peer-to-peer, and there's a project IRO SSH where I don't need to have the machine or the microVM exposed like for an SSH port on the global internet. And if somebody uses, it's basically a federated network that establishes a direct peer-to-peer like quick connection between two machines. And I can give one of my friends like the command to run, and then just register like a cert from them on that VM, and then I don't even need to have the thing exposed through Tailscale or any type of VPN like that. They can just run this IRO SSH peer-to-peer and then get a direct connection into this box. So I use this for like people that are doing dev boxes, game servers where they want to tweak it, or like a AI agent if you want it to be able to like communicate between other boxes, stuff like this.
Yeah, I was gonna do Minecraft, but then connect it to Tailscale for a friend to connect to.
Yeah, it's not a great experience when you have to give them like access to your tailnet, you know. One of the hacks I do with this, like I have a machine running on Hetzner that's just using an Nginx service, and it's literally just forwarding port traffic to specific microVMs, and then I give them the public IP of the Hetzner box, and then with the port baked into whatever Cloudflare record for that thing exists, and then they just go right to the box. They're none the wiser.
Thanks.
Yeah. Any other questions? Oh, one up here.
Hi. I showed up a little bit late, so maybe I missed this, but I'd be curious to hear your thoughts on how this approach compares to using containers. Obviously, there's a difference between, isolated kernels versus shared kernels. But I guess with that in mind, or aside from that, I'd be curious to hear your thoughts on that.
Yeah, I talked at the beginning about some of the differences between these two, or I guess the three I did: containers, virtual machines, and micro virtual machines. And really, like the main difference is microVMs give you a super minimal footprint to boot these up. Containers give you a lot of the same process isolation, like environment isolation, but it does share the host kernel. So for more security reasons, like if you're doing builds or something, it's probably better to use a microVM instead of like just a straight up container. But a lot of the boundary does kind of intersect. If that makes sense. Yeah. I think that's it for questions. So cool. Thank you guys. Maybe I should have had my slides open so I could have moved around.